Well, hi, good morning. Thanks so much for coming and joining me here and being part of what must be the hardcore of viewers sticking with me as I slug my way through this receiver. So I think what I'm going to start out with is just a quick review of where I'm at. There's been some things that have gone on here I have not posted on video. Not too much, just sort of investigatory things or the like. So I'm attempting to make two test points provide the correct kind of wave shape on my scope that you see up there. This is not on, by the way. And I'm not having tremendous luck. So one of them involves this little circuit here I had to put together based on a design that's in the service manual. And the objective of this is, I'm pretty sure, to simply detect the output of the IF stages and turn it into a nice single line on my oscilloscope, which would have a nice curve to it like that. No, that's not quite what I've got up there. Part of the challenge here is the receiver may be well out of alignment. That's what I'm trying to investigate, really. And if it's out of alignment, these wave shapes won't look standard. They won't look normal. So part of my challenge here is to recognize that what I'm seeing on the scope is correct for the circumstances in the radio, or is reflecting something that isn't working out quite so well. Maybe my little circuit's not working. I'm thinking maybe even the diode I put in here may be defective. I don't know. I didn't, like a dummy, I didn't test it before I put the circuit together. So my basic aim today is to focus in on getting these correct wave shapes onto my scope. And once I feel I have the correct wave shapes, then I can go ahead and start some more alignment stuff, which isn't going well in itself from a stuck slug. So that's really in a bit of a jackpot situation here. So I hope to get out of it today. So I'm letting my equipment warm up here in the shop before I get going, and then we will get going somewhere. Okay, after a little bit of thought, one of the possibilities here is I've used the wrong size capacitors here. So rather than even consider these, I've got a couple here that are proper. These are 0.002 microfarad capacitors. And I'm going to cut these off, put these in, and maybe that'll make a difference. Because one of the things I saw on the oscilloscope when using this circuit was an awful lot of RF still in the signal. So maybe that indicates I've got the wrong size capacitors there. Okay, so I've made a couple changes to the little circuit I'm using. I guess we can call it the interface circuit between the receiver and my oscilloscope. And there's the circuit there. And what I've done is I've shortened up all the leads, so it's soldered in with almost no leads now in here. This is the actual test point sticking out here. And I also changed the two capacitors that were in there with two that I know for sure are the correct size. So it's time to find out whether this is going to help or not. So we bring up the scope. Oops, not that way. Ground goes here. Okay. Get the oh so dangerous solder out of here. It's easy to turn a project back on and have a solder wire laying in it somewhere by accident. Okay. Just making my situation a little simpler here. Okay, that looks good. This is an FM antenna sitting here. We don't want an antenna. We want the output from Where are you? Way over here. So this is from the signal generator. That guy kind of hidden from view back there. That's the guy we're going to use. I mean, that is the correct instrument. The other two signal generators I was experimenting with, it may not be called into action here, or they may be. Especially the single frequency one, because I need a marker. I may need a marker, a generator to produce a pip on the screen to mark a particular frequency. I can get around to that, but for now we'll just use the this guy here. Okay, we're all set to go. Just change the camera here a little bit. You can look that way. Okay, I think everything's set. We're triggering on the line here. And, well, we're set on RF sweep down there right now. Okay, I think we're ready to go. Okay, volume down. Let me just check the settings here. The on switch is on this now, and we're set to FM, and the volume is almost completely down. Okay, power on. So I'm hearing the hum that usually comes out of these speakers. Let me turn up the volume here. The radio is tuned way far away from the signal generator right now. So we will tune it over there. Well, that would be it there. Let me just make sure the level's down on this here guy. So we're starting with like a minimal RF level coming out of that signal generator. Tune again. Well, okay, that's plenty there. It would sound like plenty there. Now, what happened on the oscilloscope? No, come a little closer. What happened on the oscilloscope during that? I'm going to turn the volume down a little bit so we don't have to hear quite so much. I would guess that that's indicating it's just way too much signal coming into this radio. Just turn the volume down. It's not so dramatic when the volume's lower. What to think of this? So it looks like the same thing twice. So let's speed up the speed here. Now we got one thing. Make it a little more easy to see. Ooh, wow. Now that is a combination of all kinds of stuff here. First of all, the RF is gone. So I think changing the capacitors has solved that problem. So it's nice, just a single line through here now. Fantastic. Why it looks like that? Okay, I'm going to tune the radio a bit. Now, like, that's more what we're looking for, something like that. So I'm going to vary the FM deviation. It's set fairly high right now. Let me just deviate down. Could be the deviation is beyond the range of the receiver, and that's where that's coming from. But I don't think so, because I think 75 kilocycles usually, deviation usually up around here. Again, getting this right is so important before monkeying around with any adjustments. Well, let's switch this to not sweep. Okay, now we should hear a 400 hertz signal, and also now this meter has become active. This tells me the deviation in the signal. So that would be 50 kilohertz deviation, and that would be 75, and that's what most radio stations are shooting for, or are supposed to do. I'm going to set it to 50. 50. Now let's tune through the radio signal. I'll watch the scope. Okay, let me turn it up a bit. Okay, go back through it. So what I'm expecting to hear is basically three times you get the signal as you tune through it. You get two sort of lower peaks on the side and one main one in the middle, the one you're really trying to tune to when you're tuning a radio. So I'm going to roll through again, just steadily tune through the signal, and we'll see how many and what it sounds like. And it should also be symmetrical. Should sound the same coming in as going out. I'm tuning. 1. Well, on the scope you can see that goes down to nothing. And then we get the signal, and there should be one more. That there's nothing. So that's telling me the symmetricalness of the signal is not there. It's not there. So that certainly screams alignment. Could help if I've got this set up properly. So what are we doing here exactly? Let me just step back now and really think about what it is they've got me trying to pull off here. So I've made a connection here to test point 1, but all I know is that's called test point 1. I don't really know where this is in the radio yet, so I'm going to examine this and find out where exactly have they got me connected here. And that's a good starting point. Why don't we do that first? Where exactly is test point 1 in the circuit? So I'll pop up the schematic here. So that's the little test circuit, by the way, and that's the capacitor I just changed to a proper size. You know what I did here? I made a mistake here again. I put two 2200s in there. Before I had two 1100s. That's why I had two to make 2200. I've actually put more capacitance here than what it calls for. Doesn't seem to have hurt at all. These are the two wave shapes that I'm trying my best to get. This is the one we're trying to get right now. Look like that. And this is the other one which we haven't tried yet. The infamous S curve in the detector, the multiplex detector. So we're going to look at where this circuit actually goes. And, TP1. Okay, so we're going to go and first there's a diagram showing where TP1 is. Here it is here. In my mind, it's actually here. It's more in the middle here than over this far. In my mind. Now we'll try to find TP1. So I know where TP1 is. This was really tricky to find. There it is, P1, right on the edge of the diagram. So now there's a little piece of a transistor here. And if we look at the other board, here it is here. Here's the other part of the transistor. And that's what TP1 is, right there. Q20, 20 nothing. That's 204. That's 203. That's 202. 211. How am I supposed to? Come on, I'm trying to figure out what this must be over here. 20 something. So 203, 204, 205, 20, we don't know. 206. 207, 208. It's got to be 205. Okay, now we'll go down on the schematic. We'll find, yeah, we're going to find 205. So 205 is going to be in the radio, and it's going to be, well, where did he put the Q numbers? Oh, it's upside down, for crying out loud. That's better. 06, 04, 11, 03, where's 5? 08. Another Q11. That says Q, that's a QX3. Uh-oh. Wait a minute. Somebody stole Q2, 3, 4. 5 is missing, so that's why this radio doesn't work. They left out, they got an extra transistor. This is crazy. That says 6. That says 6. That says 7. That says 8. That says 9. This must be 6. This must be 5. This has to be 5. They're showing it on the schematic located after the IF string, just before this special transformer, which is involved in converting the FM signal to an AM signal. That's actually what it's doing. So this must be it. This must be 05, even though it looks like 6. So we're hooked up. There's test point 1. Oh, right. That solves the mystery right there. So we're looking at the output of this transistor as it heads into this transformer. And my guess is the AM signal is picked off before this transistor. The AM signal, for all I know, that's the diode right there. Or the AM signal coming down here. Look, yeah, it's working its way. Looks like it's working its way into all this audio stuff. Maybe, I don't know. Not to worry about that. So the FM signal comes out of the FM-IF at 10.7 megahertz, supposedly, is built up with this and then fired into this guy. There you see it says 10.7 right there. So we're test pointing the output of the IF, which is what I thought it was. And this output will contain not only the will only contain the FM output. The AM output is in this transformer and shot down, I think, this way. So out of this transformer comes the 10.7 FM IF boosted here off to the test point. That's why you have to filter this so much to get rid of the RF that's coming here, because it's not fully filtered yet. Not until you get through all this schmozzle, I think. 19 kilohertz. Okay, lots. Don't look ahead, Jim. You get scared. Don't look ahead. Just look at your feet and take a step. So what's this mean then? That means that I think we should get that diagram exactly as it shows. Way up here. This guy. Doesn't necessarily have to swing downwards on my scope. It could swing upwards, but it should swing downwards. Okay. If this receiver is working well and is all tuned up, I think we would see exactly the kind of signal I'm talking about. So I think we are in a position now to fiddle with some alignment stuff. And what stuff? Let's take a look at that. So this is the transformer that I've been adjusting inside the can of the RF, of the FM amplifier. One of these slugs has not moved. The other one is moving freely. If I adjust the slug here, you can see changes for sure. What is this doing? This is trying to pass the 10.7 signal that's been developed in here out. This is probably the mixer transistor, but I'm not sure. I'm not sure how this is all done. This is probably the oscillator, but again, I'm not really sure. So out of here anyway is coming 10.7. The 100 megahertz original FM signals are all contained in here and never go any further. popping out of the can is 10.7. So this thing we're looking at is a 10.7 signal. We can pick that up with a radio, pick that up with the SDR and look at it. And why would I do that? Only because I think the shape I'm seeing on the scope is disturbed from things outside of the alignment, and I'm about to make a mistake. But I think I've looked at this enough, I've learned enough about it, I got enough handle on everything that I think if I start heading into a jackpot, I can recognize it and save myself from ruining this FM receiver. That's really what it amounts to. Okay, I think I'm overly cautious. Am I being overly cautious? Well, I don't know. Can you be overly cautious doing this kind of stuff? Let's take a look at the scope again. We'll get this guy going and we'll look at the wave shape and think a bit about it. I'm going to change some lights here. Not sure if that helped out. Close this door. Okay. Why are we not seeing anything here? Everything is on. What did I do to? Let's turn the sound up first on the radio. Okay, so there's nothing there. So it looks like maybe I just simply tuned it away from the. Yeah, I just tuned it away. So in this mode now, the signal generator is not putting out a. It's not wobbling. It's putting out a fixed RF frequency, and it's modulated with a 400 hertz tone, and it's done in mono, and the 19 kilohertz pilot is switched off at the moment. So things are as simple as they can be. If we tune through, does this allow us now to find the best tune spot? Can we look at that thing on the scope and go, now that's the right spot? So if we use our ears, I mean, the loudest is here, but the nicest sounding is over here. Okay, let me turn it down a little bit here. Turn it down a little more. So if I turn the signal generator to wobble here, let's using 60 hertz to generate a sweep. Yeah. What is that supposed to be? Let me slow this down just a wee bit. Yeah. we'll tune. And we're not looking for an S-curve here. Even though we're getting a whole alphabet coming up on my scope. Oh my gosh. I cannot interpret what we're seeing on. I can't say, oh, I know what that is. That's because the signal generator, blah, blah, blah. Can't do it. Okay, so we have an alternative way to fix the tuning up on this guy. And one is we can know for sure where the signal generator is tuned. We have a way of doing that. And we can also know for sure where this receiver is tuned. I have a way of doing that. So I get both things exactly on 100 megahertz. Then it must be the case that whatever shows up on the scope is the valid signal shape. I just gotta switch just a little bit for a moment, because it's very important. One of the greatest lessons I ever learned in college. We're in a lab class working away on our whatever it was we were working on, and suddenly the instructor says, "Hey everybody, there's a problem with these meters. Do you know what the problem is?" And he's holding a meter up at the front of the class, and I mean, we're all looking like, what the heck is he talking about? He goes, "The problem with these meters is they always give you a reading." And then he sat down. And I figured out right away what he was saying. What he was saying was, just because you get a number on your meter doesn't mean you've done things right or anything like that. Just because I get the correct wave shape onto here after fiddling around long enough doesn't mean I've succeeded in getting the radio set up in the right scenario. So I really have to do something very convincing, I think. So we'll start with knowing for sure the signal generator is transmitting at 100 megahertz. Now, even that's a little bit challenging. Let's see what we can do here. Another radio. It's at 108. And I have to hold this button here. You think, well, why don't you just direct enter the number? Because I can't. I don't know why. In FM, when you try to direct enter the frequency, it just won't accept it. So apparently I don't know how to operate another one of my radios here. So we get down to 100. Is that it? Is that even the signal generator? Okay, we're going to find out now. Tune the signal generator. It tunes from like 99.5 to 100.5. Yeah, I got to turn the sound down on the other radio. Yeah, isn't that helpful? So I'll put this from wobble onto a fixed signal, mono only. Now let's tune this. Okay, now it's pretty easy to spot exactly 100. So I'm going to do that. Yes, I'm going to move this radio a distance away from my shop bench here, just another part of the shop. I'm trying to weaken the signal. Not very weak. Yeah, it's weak now. Okay. I have another way of doing this. Why don't we do this another way too? What we'll do is we can check. We'll check with the SDR. I really want to be sure of this. So let's just go over to the SDR here. Okay, unhandled exception occurred. Okay, well this seems to be operating. Let's stop it and check to make sure it's set for quadrature sampling, which will do the higher frequencies, and that I'm hooked up to the Clopper antenna input, UV input, yes. Oh, did I just, no, it's still operating. Okay, now we want to go up to basically 100 megahertz. Here we are at 100. What do you see there? So this is the output from the signal generator. You can see it's just a hair off 100. It got pretty darn close, didn't I? But I think with this display, I'll make another frequency adjustment here. Look at that. Okay, somebody's going to argue with me that this is not putting out 100 megahertz on the money. Okay, now that's good. Now the next thing we need to do it with the SDR. is set the local oscillator. Local oscillator should be running, if the radio's tuned to 100, it should be running at 110.7. So we're going to go up here to 110. Well, look at that. So there's the oscillator. And 110.7. That's where it should be. The local oscillator in the radio should be over here. So I'm going to tune the radio, and that'll move the local oscillator into the frequency that we're after. I could be smart and I could mark the dial position too. Come on. Oop. There's an awful lot, like I'm turning the tuning knob and nothing's happening. There's an awful lot of play, as I noticed earlier. I don't know if I put it on a video. There's a huge amount of free play in this tuning knob here. Give you the false impression you've got some kind of frequency control going on. So that's dead on 10.7. The accuracy of my SDR, you can question it. It can be out. But let's not question it. Let's just pretend it's exactly correct. So now the radio's tuned to exactly 100. The signal generator is kicking out exactly 100, isn't it? Still dead on 100. Perfect. So now we want to turn our attention back to the oscilloscope. Oh no, we don't. We want to flip some controls first. First of all, if I flip to wobbler, does the frequency go off? Let's see. So now we're wobbling around 100. I can't quite see it all. So I'm just going to slide the display over to the right a bit. Well, isn't that interesting? So what's happened with the wobbler now? Let me, if I can shrink the wobble. Shrink the wobble. Isn't that interesting? So I shrink the wobble, it comes right down onto the proper frequency. But when I expand the wobble, you can see it's not symmetrical. Just put it on the list. Put on the list of stuff. Okay, I'm going to expand it out again. And we're trying to set it, well, I don't know where it's being set. We'll set it there. Okay, so wobble not in the middle. And that's not because of the radio. Is that not because, that's because of the signal generator. Wow. It's a whatever is controlling the wobble in my signal generator is unbalanced. And it sounds like maybe I better, for the sake of precision, I'm going to have to go through that signal generator too. Yikes. At least I'm not going to run out of work to do. Okay, next thing. Let's go back to the scope here and see what we got. We got one of those out of it. Let me turn up the volume here. We're on the wobble. We're looking for one nice neat curve like that. That doesn't look like a nice neat curve. Let me slow the sweep down even more. Holy smokes. So what I'm thinking is you'd get a repetition, just the same thing over and over. Oh, look at that. I can point at stuff. Huh. Fantastic. That's fantastic. I'll have to remember that video trick right there. Excellent. So what I would expect is whatever comes up on the screen would be repeated, and it would look exactly the same over some distance. That doesn't look exactly the same. That looks like one trip through something. Let's slow it down even more. Okay, so now I'm seeing replications of the same thing. So it starts there and ends there and has all this schmozzle in between. And it's supposed to be a nice, curve. Okay, so what can I adjust without retuning the radio or retuning the So that's on wobble. It's off right now. Let's put it on to just stop it wobbling. Put the tone on. A little hard to see in the camera, but it's just producing a nice looking sine wave. Wobble too great. Let's go back to the wobbler. Well, that's a good question. How much is too much? Wow, I'm just not getting that feeling of certainty here. I got the impression now that this little circuit's doing its job properly. The conclusion you might want to reach now is that this is all alignment stuff, but I don't know about that, because isn't this not supposed to be, like, this is supposed to be, you know, it's going through a diode. So shouldn't you just see stuff below or just see stuff above, but not both? I flip this onto DC. Wow, that looks a lot different. Back to AC. Oh no. Wasn't expecting that. Expecting it the waveform to remain the same, just maybe change its level height on the draw lots of pretty pictures on my oscilloscope here. So that sounds like some kind of, I'm just guessing here, it sounds like a distortion coming in. Is that the response curve? This is identical to this. Let's speed it up. Is that the response curve? It looks like it could be. It looks like it could be. Okay, well, let's just gamble a little bit here. I'm going to go ahead and I'm going to adjust that transformer with the stuck slug and the not stuck slug. This is the first item of adjustment in the list. There we go. Okay, so I'm in the top slug now. Oh yeah, look at that. Oh, it's doing lots of stuff. Question is, what's all that? Where's the goodness? Goodness grief. Okay, I'm going to go down the other slug. Maybe it came loose overnight. Okay, I'm in the lower slug. No. I'll break my tool if I go too far with this. I have nothing else that can get in there. Little tiny screwdriver that might just be exactly the right size. Now, that would be crazy to stick it in there. Just to crack loose the slug in there, and crack loose is the word for it. It might crack it. Oh my gosh! So another possibility is to spray, WD-40 or something into there. I'm not anxious to do that. Wow. Okay, so I'm still not in the comfort zone here. I'm still not sure what I'm doing is what I'm doing now is I'm unwinding a cord from the leg of one of the tripod here. Hey, it did that. It did that okay. What to think? What to think? I'm not sure I've got the right shape, right thing on the scope. Not sure the circuit's working right. Not sure the signal generator is producing the appropriate kind of signal. Not absolutely sure, but I'm pretty sure. Got them tuned properly at 100 megahertz. Can't make the first adjustment because the slug is stuck. Adjusting the other slug on its own, well, you know, that's like wandering around to the side of the trail, but you can't get on the trail no matter how much wandering you do. If I have the wrong kind of display here, things are not working at all, but somehow I've managed to get that onto the scope, and then I sit here and fiddle around trying to make that into something it's supposed to be. I could be just messing everything up left and right. What I found from experience at the end of doing an FM alignment, one that you actually can get through, and I have gotten through a few, is the very last stage is to twiddle a few things while listening to music playing out of the speakers and just using your ears. That has always disturbed me, but that's how this has ended up on quite a few FM radios. Follow the procedure as much as you can, but in the end, make it sound good. Literally, that's kind of how it goes. It's also possible that no, I was going to say it's also possible that subsequent alignment issues with the demultiplexer and with, but no, we're looking at a signal ahead of all that. So this thing on the scope can only be affected by the adjustments A in the FM, B in the FM tuner, which I haven't adjusted anything but the one little transformer, and C, the alignment of the IF. Hey, alignment of the IF. The alignment of the IF. Why can't I proceed with that? That's a fairly straightforward thing. Maybe I should go ahead, try to check or improve the alignment of other areas of the radio, and come back to this and see. Can you even do that? Can you even do that? As long as you have a 10.7 signal going through the IF, you can tune the IF. You can get the 10.7 signal from a signal generator and know for sure it's 10.7. We already know the pointer's not set properly on the front of this radio. We can take a wild guess that the radio was aligned with the pointer in the incorrect position, which means it's aligned for the incorrect pointer position. I can come along here and attempt to correct the pointer position. I haven't done that, and I'm not inclined to do it, but if I did, I don't even know where I'm going with this discussion. If I did, it would just make things even more difficult. Well, I guess the other way of saying that is if you did align the pointer, what I'm talking about is the pointer here, the pointer here aligning with these control dots that are on the face of the panel. And as I've said before, to do that, you have to loosen off these set screws and do something with this, which is frightening to me. I guess I'm just letting a bunch of ideas roll around here in my head to see if maybe some of them will connect in some way. IF alignment. I think I'm going to go ahead and do that. I think that's what's in store here. But I'm not going to do it now. I'm going to give this a day to soak in my head. I'm going to read up on the IF alignment process. I'm sure it's straightforward. And that's what I'll do. I think that's what I'll do. Thanks a lot for watching this somewhat unproductive video, but this is how it goes. So thanks for sticking with me. We'll see you on the next video.